Hello everybody, this is Mrs. Snook with section 4.6 day 1. And what we're going to do today is we're going to graph other trigonometric functions. And today we're going to focus on the tangent and the cotangent. So our objective is to sketch graphs of tangent and cotangent and to also sketch those same graphs but with transformations. So the first thing we're going to do is get ourselves a bunch of points that we can use for graphing the tangent. And these points you can get from the chart on page 287. You can also get them from the unit circle. And I do encourage you to memorize these points because you will have to know them. So I have filled in our chart for the sine and the cosine. And then please recall that tangent is your sine theta over cosine theta. So all I'm going to do is I'm going to take my first row and divide it by the second row. So for 0, tangent of theta is going to be 0. And then for a pi over 4, it's going to be 1. And then pi over 2, I have a 1 over 0, so that's going to be undefined. And that also means I'm going to have an asymptote at this point. And then I have -1, 0, 1, undefined again, -1, 0. All right, so now let's start graphing. I want you to notice everywhere I have an undefined, I'm going to put in an asymptote. So I have an asymptote at pi over 2. I'm going to put that in here. And I have an asymptote again at 3 pi over 2, which is right here. Now also remember, since sine and cosine repeat, tangent also repeats. And look at my distance between my asymptotes. It's exactly 1 pi. So that means I'm going to have an asymptote back here at -pi over 2. And another one at -3 pi over 2. All right, now let's start plotting our points. At 0, I have a point at 0. And then pi over 4, I have a point at 1. And then I hit the asymptote when I get to pi over 2. So it's going to go up like this. So this first piece looks like that. And now let's go on to the next section. I have asymptote at pi over 2. I have a -1 at 3 pi over 4. So there's a point here. And then I'm 0 at pi. And then I have 1 at 5 pi over 4. So start by the asymptote. Go through the points. And then head towards the other asymptote. So right there we can see what the whole cycle of the tangent graph looks like. So that means that when I come over here to -pi over 4, that's going to be the same thing as 3 pi over 2. So I'm going to get a point here. So I can continue this graph like that. And then let's come over here, 7 pi over 4. I have a point at -1. And then I have 0 at pi over 2, so this is going to look like this. And it's just going to keep going. So what I'm going to do is, because this is cyclical and it keeps repeating, I can take the graph that's between -pi over 2 and pi over 2, and I can reproduce it over here in this section. So I'm literally just copying the points. Start at the asymptote. Draw a curve through your points, and then come back out at the asymptote. So this is what our tangent graph looks like. And let's go ahead and fill in some information about this tangent graph. First of all, the domain. That's the x's, or in this case, thetas. I'm not allowed to have it anywhere there's an asymptote. So my domain is going to be theta is not equal to, well, it can't equal pi over 2. It also can't equal 3 pi over 2 and 5 pi over 2 and 7 pi over 2. So every time I add a pi, I get an asymptote. Same thing with every time I subtract a pi, I get an asymptote. So I'm going to say theta is not equal to pi over 2 plus or minus n pi. So that's going to take care of every time I go pi difference, I'm going to get another asymptote. My range, that's going to be the up and down, the y-axis. And all values are allowed there. So this is going to be all real numbers, or I can just say negative infinity to positive infinity. Next is period, and the period means how far until it starts repeating itself. And notice it repeats, it has negative pi over 2 to pi over 2, that's one cycle. Then it repeats again the following pi, and it repeats again the following pi. So our period is actually pi in width. Now look at the x-intercept. That's where it's going to cross the y-axis. And it only does it in one place, 0, 0. Oop, I misread that. X-intercepts, or in this case, let's just call it theta. It's going to cross theta at 0. It'll cross again at pi. It crosses again at 2 pi. So I can write this as theta equals n times pi, plus or minus, where n is any whole number. So 1 pi, 2 pi, negative 1 pi, negative 2 pi. Those are all the places that this graph is going to cross the axis. Now your y-intercept, it only crosses the y-axis in one place, and that is at 0, 0. Asymptotes, those are pi over 2, 3 pi over 2, any multiple of pi over 2. So I'm going to say my asymptotes are going to be theta equals pi over 2 plus or minus n pi. And I want you to notice that's exactly the same thing as the domain. So anywhere your domain isn't allowed, you're putting an asymptote there. So you can just copy this over. All right, so that was your basic tangent graph. Now let's do some transformations. So the general function for a tangent graph is y equals a tangent of b theta minus c plus d. So we have the same a, b, c, and d that we had in sine and cosine. So I'm going to look at my equation, and I'm going to figure out the a, b, c, and d. In this one, a equals 1, b equals 1/2. That's how I get that theta over 2. There's nothing being added or subtracted to theta, so then c equals 0. And we're not adding or subtracting anything to tangent of theta over 2. So we don't have any shifting up or down. So d equals 0. So what happens is we have a 1/2 for b. And if you recall, for sine and cosine, period was 2 pi over b. With tangent, period is pi over b. So then the period for this graph is going to be pi over 1/2, and that equals 2 pi. So what's happened is, if you look at the original graph, our period was just 1 pi. Now we've actually stretched it horizontally by a factor of 2. So we're going to have a horizontal stretch. By times 2. So what I'm going to do is, when I place my asymptotes, instead of going at pi over 2 and 3 pi over 2, I'm going to double those because I have a times 2 stretch. So I'm going to have an asymptote at pi, another one at 3 pi, another one at negative pi. So we have an asymptote here. We're going to have another one. Okay. Okay. So our period here is twice as wide. The asymptotes are twice as far apart. Okay. And then what that means is my points are also spread twice as far apart. So in my original, I had a point at 0, and then I had a point here at pi over 4. So 1 and pi over 4. Now it's going to be 1 and pi over 2. I'm going to have a point there. Similarly, I had a point at negative 1, so y was negative 1, and theta was negative pi over 4. Now that's going to become negative pi over 2. So start at my asymptote, smooth curve through my points. And this also will repeat. So I would have right over here, okay. Next one, we're going to do 4 times the tangent of 2 theta. So again, let's find A, B, C, and D. I have a 4 in front, so A equals 4. That's going to give me a vertical stretch. B equals 2. C equals 0, and D equals 0. So my transformations are going to be, I have a vertical stretch, which is a times 4. And let's get our period. So period equals pi over b, which equals pi over 2. So now my period is being compressed. So now I have a times 2 horizontal compression. So what that means is instead of having asymptotes at pi over 2, 3 pi over 2, they're being stretched. So my asymptotes are going to be at pi over 4. So I'm going to put in my asymptotes now. Right here is pi over 4. My period is pi over 2, which means I'm going to have another asymptote here at negative pi over 4. I'm going to have another asymptote here at 3 pi over 4, and just every pi over 2, I have asymptotes. That means I'm going to be able to fit quite a few periods on my graph here. Okay, now on the original tangent, we had points at 0, negative 1, and positive 1. So we would have a point here at 0. And then halfway to your asymptote, you have a point at 1. But we've got a times 4 stretch. So instead of having a point at 1, it's going to be up here at 4. And instead of at negative 1, it's down here at 4. So here's what this graph looks like. And it's going to repeat. And it repeats. Also repeats over here on the negative side. And it repeats over here. So here we go. 4 tangent of 2 theta. All right, now the next one we're going to do is graphing the cotangent. And I'm going to do the same thing. I'm going to get myself some points from that chart. I'm going to calculate my cotangents, and then I'm going to see what that graph looks like. All right, I filled in our chart. Take a look at your undefines. Those are at 0, pi, and 2 pi. So my domain is going to be theta is not equal to, let's see, 2 pi plus or minus 2n pi. So every 2 pi, we have an asymptote, so theta can't be in that domain. Let's go ahead and put in those asymptotes. So right here on the axis at 0, again at pi, again at 2 pi. So let me correct this. I said 2 pi plus 2n pi. This is going to be at pi plus or minus n times pi. And then here at negative pi. And then here at negative 2 pi. Okay. Now let's plot our points. At pi over 4, I have a 1. And at pi over 2, I have a 0. So pi over 4, I have a 1. Pi over 2 is 0. 3 pi over 4 is negative 1. And then I'm going to the asymptotes. So asymptote through these 3 points, asymptote. And then notice, if you look at the chart, you're going to see it's going to repeat. I have undefined, 1, 0, negative 1. So it just repeats again. Undefined at the asymptote, 1, 0, negative 1. And just like with the tangent, I can also repeat it on the negative side. So it repeats over here. And it repeats over here. Okay. So now look at the graph. Range, which is the y, is all real numbers. So negative infinity to positive infinity. Our period was pi again. Our theta intercepts, this time our intercepts were at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So it's going to be at theta equals pi over 2 plus or minus n pi. So that's going to allow it to repeat. Y-intercepts. Look at your picture. There aren't any. So none. And then the asymptotes. The asymptote goes every place where you're not allowed to have a theta. So I would just copy it from my domain. Theta equals pi plus or minus n pi. And in case you're wondering, n is just a number. 1, 2, 3, 4. It's always going to be a whole number. It can be positive or negative. And it takes into account the fact that this graph keeps repeating. All right, let's do the cotangent of 2 theta. And just like with tangent, cotangent, you can write as y equals a cotangent of b, theta minus c plus d. So we're going to find a, b, c, and d, and those are going to give us our transformations. This one, a equals 1, b equals 2, c equals 0, d equals 0. Our period is still pi over b, so we're going to get pi over 2 as our period. So what we're going to have here is a horizontal compression. That's a times 1/2. And we don't have any stretches. We don't have any up or down shifts or left or right. So I have a compression of 1/2. So my asymptotes, instead of landing on 0, pi, 2 pi, I need to cut those in half. So it's going to be 0, pi over 2, pi. Same thing on the negative side. So sketch in your asymptotes. One right here on the axis, one here at pi over 2, another one at pi, another one here, and another one here. Now I'm going to plot my points. I know I have a intercept right there, and halfway I have a 1, and halfway I have that one. Okay. Do the same thing over here. Point, point, point. Same thing over here. Same thing over here. Okay. So that's what this graph of a cotangent of 2 theta looks like. And you can just do a quick comparison with just 1 theta. You see how it's the exact same thing, it's just been squished inward. Okay, the last one we're going to do, this one is going to be the most challenging one, because check it out. A equals 3. So I'm going to have a times 3 vertical stretch. B equals 2. I'm going to have a horizontal stretch of times 2. C equals 0. And D equals plus 1. So now everything is going to shift up 1. So let's put in our asymptotes. I'm going to do that by figuring out my period. So period equals pi over b, which equals pi over 2. So now my asymptotes are going to be every pi over 2 starting on the axis. Come back here. And lastly here. Okay, so when I plot my points, I have to remember my times 3 stretch plus up 1. So let's write this down. We're going to go up 1. We have a vertical times 3 stretch, and we have a horizontal times 2. Okay, so on my original, I would have a point right here at 0. But I'm going to go up 1. So that's going to put it here. I also have a stretch of 3. So 1, 2, 3. That puts it there at 5. I did the 5 at the wrong place. And now let's do our stretch. So right here, I would be here. So I'm going to get a point there. And then I have a times 3, so I'm going to go down 1, 2, 3, and I have a point there. So that's what it's going to look like. And it's going to repeat. So I'm going to have the same thing over here. And I'll have the same thing over here. And it just keeps on repeating. I'll draw it one more time. All right. So that's our cotangent with a times 3 stretch and an up 1. So that is all for today's video. Thank you for watching and have a great day.